stabilizing meringues with different additives. Meringues are sweet bakery treats and whimsical toppings. However, they are oftentimes very hard to make. The goal of our project was to observe which additive, cream of tartar, garlic juice, or lemon juice, creates the most stable, the best, meringue. In order to understand meringues, we first have to understand the science behind the proteins in egg whites. Raw proteins found in egg whites are separate units. These proteins can be affected by their surroundings. Adding things like acid, heat, or even air can cause the proteins to become denatured and unravel.
Meringues are essentially foams. They are made up of whipped egg whites which become coagulations. The proteins in these egg whites are so fragile that they become denatured by the air around them. In the air, the proteins will unravel and bond together with other proteins around them. Furthermore, meringues are held together by these loosely bonded denatured proteins around the surrounding air bubbles. Meringues are very complex because egg whites are so complex. An alkaline, basic pH, such as the one found in egg whites, promotes the oxidation and aggregation of certain bonding groups and molecules during whipping, which creates a grainy and easily collapsible foam. In order to form a stable foam, an acid is added to the egg whites. Lowering the pH via an acid pushes the equilibrium in the opposite direction and delays or inhibits aggregation, and renders foams that are more stable. Usually, cream of tartar is added to meringues when baking to ensure this acidic environment.
The purpose of making a meringue is to form a stable, fluffy foam. So, how can we make the perfect meringue? Well, food science specialist Cesar Vega aims to answer this question. Vega conducted an experiment with meringues. He whipped egg whites with different substances such as garlic juice and cream of tartar. In Vega's experiment, he hypothesized that garlic juice would be an effective egg white stabilizer because of a compound called allicin in the garlic juice. Allicin is good at preventing aggregation. Vega found that garlic juice was successful in creating the best foam. The garlic juice stabilized Vega's meringue best because of the absence of cross-linkage. Foams are less stable when cross-linked, as shown here, because the foam expels more water, or the proteins push water out when cross-linked.
For our project, we replicated Vega's experiment. We created 4 different meringues using egg whites only, cream of tartar, garlic juice, and lemon juice. We chose to add lemon juice to the experiment to see if it would provide an effective acidic environment to stabilize the egg whites. The ingredients for our project included egg whites, cream of tartar, lemon juice, garlic, and an electric mixer, filter bags, and 4 measuring cups. First, we poured 3/4 of a cup of egg whites, which is equivalent to 4 eggs, into a measuring cup and poured it into a bowl. We then repeated this 3 more times for all 4 trials. For trial 1, our control, we only beat the egg whites. We didn't add any other substance. For trial 2, we added cream of tartar, which is part of the standard recipe for meringues. In trial 3, we added garlic juice to the eggs in order to replicate Vega's experiment. In trial 4, we added lemon juice to see how the meringue foam would be affected. After creating all 4 mixtures, we mixed each one for 5 minutes. After 5 minutes of mixing, our control, which was made of just egg whites, was very fragmented and watery. The cream of tartar was the creamiest and most shaving cream-like and very thick. The garlic was also shaving cream-like and easily folded. The lemon juice was similar to the garlic in that it was shaving cream-like and also easily folded. Next, we placed each meringue into a filter bag. We then hung all 4 filter bags and left them for 20 minutes. We put measuring cups under each one to measure how much drainage took place. After 20 minutes of dripping, our control had 95 milliliters, our garlic mixture had 65 milliliters, and our lemon juice mixture had 60 milliliters. Our cream of tartar only had 50 milliliters. The control had the most drainage, making it the least effective, while cream of tartar had the least drainage, making it the most effective.
Our results shared similarities with Vega's experiment and also had differences. First, cream of tartar worked well in both experiments. The cream of tartar made thick, stable foams that had little drainage. It makes sense that the cream of tartar works so well because it is already usually used to stabilize foams. Our garlic juice mixture did not work as well as Vega's. While our mixture was stable and looked like a good meringue, it had a substantial amount of drainage. Finally, our lemon juice mixture was similar to the garlic juice. The lemon juice appeared to have produced a stable foam, but it also had a lot of drainage. We were in 80-degree heat when making these meringues, which could have made the egg proteins unravel faster. As a result, for more accurate data, more trials should be conducted.
Our experiment adds to the meringue foam food science field. When you make foams, you end up piping them, adding flour, and folding them more, and putting them on cakes. In order to get the best looking and best tasting meringue, the consistency must be correct. A stable shaving cream-like meringue is most desired.
Our research shows that cream of tartar, the usual meringue stabilizer, achieves this state best. With more research, maybe garlic juice or lemon juice can become good stabilizers. But for now, enjoy!